Yeah, hi. First of all, thank you for Conf42 team for providing an opportunity to present a topic on optimizing SQL Server infrastructure for LLM workloads in hybrid environment. Thanks for joining. My name is Siva. I'm working as a principal database administrator in Paycor, which is now a Paychex company. In this talk, I will present about how SQL Server get ready for LLM workloads. Let's start the presentation. Yeah. The agenda of this talk is the LLM infrastructure challenges and legacy SQL Server limitations, Azure SQL managed instance and MI-link real-time replication, performance optimization and global architecture pattern, security, governance and real-world implementation of MI, future-proofing your data infrastructure. This is the agenda for this presentation. Okay, what are the challenges we have right now for LLM infrastructure? The traditional SQL Server is having a limitations like a high latency data access patterns, limited scalability for concurrent AI workloads, complex replication across environments, performance bottleneck in real-time scenarios. So the modern LLM requirements are sub-second response times for prompts, continuous data synchronization, elastic scaling for a variable demand, enterprise-grade security and governance. So why legacy SQL architecture struggle with AI? In legacy deployments, we haven't designed for a unique demand of LLM workloads. Prompt engineering requires instant access to synchronized, and queries should be optimized for data access across the distributed systems. So the gap between AI application velocity and database response times create a critical bottleneck that impacts the user experience and limits of AI capabilities. To address these solutions, Microsoft provides a managed instance that is built for hybrid AI. In this hybrid cloud integration, it helps to synchronize the data from on-premises to Azure without any latency. And this is also have the built-in governance and compliance and data protections. So this helps you increase your performance based on requirements or need. So to set up managed instance, the communication between your on-prem server to managed instance will be taken care through MI link, that is called managed instance link. This link take care of synchronization between your and on-prem environment. The synchronization will happen based on log-based synchronization, which is similar to your always-on configuration. The latency would be near. So with this less latency, your Azure environment MI instance is ready for your LLM access because it helps current and consistent data. So the advantage of it is have a performance optimization. You can have utilize query store insights that leverage historical query performance data to identify patterns, optimize execution plans, and eliminate bottlenecks before they impact your LLM response times. The other benefit, memory controlled workload classification. So MI intelligently allocate resources based on workload priority, ensuring prompt serving queries receive a dedicated memory and compute resources. The other benefit is concurrency optimization. Fine-tune connection pooling, parallelism settings, and isolation levels to handle hundreds of simultaneous LLM requests without degradation. So, architecture pattern for a global prompt data sourcing. Organizations with a global operations need prompt data available across regions with consistent performance. To fulfill this requirement, the MI-link enables multi-region replication topology where on-premises SQL Server feeds regional managed instances. This architecture reduces a cross-regional latency while maintaining data consistency, allowing LLMs to serve users from the nearest data source regardless of where the original data resides. In simplest terms, you can set up multiple MI links across multiple regions from one source database. Key performance metrics for LLM workloads: target query latency, the response time, concurrent request, it will support multiple queries on the same time, and the availability. Microsoft will take care of HADR for your Azure managed instance, and there is a less minimum delay to synchronize the data. These are the key performance metrics for LLM workloads. The other advantage with managed instances is you can utilize it as a for hybrid data, disaster recovery, as well as AI continuity. For example, your primary SQL server, that is your production environment, you have a setup for MI link with the MI instance. So that MI instance will help to synchronize the data, and it act as a read access for your LLM workloads, and as well as works as a DR environment. So in case of disaster, you can utilize and you can fail over your write loads from on-premises to Azure. So it acts as a both role, AI access as well as a DR. The other advantage of MI is it will 100% integrates with Azure Synapse integration. So with this, you no need to have traditional ETLs. The integration analytics with Azure Synapse Link enables advanced augment generation scenarios, pre-aggregated and index frequently accessed prompt context in Synapse, reducing query complexity and improving response times. This separation of concerns allow transactional SQL workloads and analytical prompt preparation to operate independently, preventing resource contention and optimizing each of its specific purpose. This is one of the example for a real world implementation. For example, you assume that there is a global bank presence across the world and they want to set up a LLM chatbot with their customers. And the major data is an on-premises environment. In this case, you can use MI link and set up a managed instances across the regions so that the bot can access the local MI instance instead of everything hitting to your source on-premises data. So this helps the response times and reduces the latency. With this solution, you can reduce the prompt response latency, and it is compliance with the regular standards, and it supports concurrent AI sessions. Security and governance in a AI pipeline. This helps data classification. You can use automated discovery, labeling of sensitive data elements used in prompt, access control, row level and column level security enforced across the replication edge targets. Audit trails, you can set up a comprehensive logging, all AI-driven data access for compliance and reporting. Encryption, always encrypted columns and TDE, protected data in transit at rest. So these are the features you can use in your MI instance based on your requirements. So to tune your LLM, these are the things we need to follow. First, enable query store. This allows to capture all your queries. So it helps to fine tune if any query is taking longer time. Configure resource governor for workloads. So if you configure this one, you can separate your prompt queries and other queries so that users can get a quick response. Implement connection pooling best practices. So you can size your buffer pools based on your requirement. Optimize index for read-heavy patterns, like create a proper index based on your, which improves the response times. Monitor MI link logs to ensure that everything is working in sync. So future-proofing your AI data infrastructure. So the implementation, first phase, you have to assess, evaluate current SQL workload and identify AI integration points. Phase 2, optimize, implement MI replication and tune for low latency access. Scale, expand multi-region architecture with analytics. Phase 4, innovate, leverage hybrid infrastructure for next generation AI applications. So the key takeaways is modernize without disruptions. MI-Link brings legacy SQL and modern AI requirements without requiring full migration. Optimize for real-time query store and workload classification and concurrency tuning eliminates LLM bottlenecks. Scale intelligently. Hybrid architecture supports global workloads while maintaining enterprise governance. Thank you. Thank you for providing this opportunity.